In this one, A is a set with 5 elements and B is a set with 3 elements. So let's start with A. We want to determine the maximum number of elements that A union B could possibly have. Write the answer in the box. All right, so first let's just look at some different situations, make some examples and see what we get. And I'll try and illustrate the concept for you. Okay, so my first thing that I write down isn't going to be the right answer. But I'm trying to motivate the ideas here. Okay, so let's say that here's A, here's B. We got 1, 2, 3, 4, 5, and 6 there. Okay, so that meets the criteria, right? A has 5 elements. A has the elements 1, 2, 3, 4, 5, and B has 3 elements. B has the elements 4, 5, and 6. Okay, so A union B is the set 1, 2, 3, 4, 5, 6. Right, so it's all the things, okay. And A union B has 6 elements. Okay, so now let's think about, okay, what would happen if we took one of these elements, let's say the 4 there, and put it over here, right? Then A would still have 5 elements, 1, 2, 3, 4, 5, but B would only have 2, 5, and 6. So let's add another 1 to B. So B has 5, 6, and 7. Okay, so now A still has 5 elements and B has 3 elements, and A union B is the set 1, 2, up to 7, right? So A union B has 7 elements. Okay, so you see what's going on here, right? Now, let's go like this. Let's go like this. Okay. Let's take this 5 out of here and put 5 over there. That didn't work out very good, did it? Let me move him over there. Maybe so let's go 4 and 5, 6, 7. Okay, so A now still has 5 elements, but B only has 3, or B only has 2, right? We want B to have 3, so we put 6, 7, 8 there. Okay, so up to 8, and now it has 8. All right, now, so you see what's going on here? Oh, that was B, yeah. The time when we have the maximum number of elements, so the maximum number of elements that A union B could possibly have is when A and B are disjoint, when A and B have nothing in common. All right, so I'll just write that out. Occurs when A intersect B is the empty set. So it occurs when you have something like this. You have A over here, which has 5 elements, 1, 2, 3, 4, 5, and B over here that has 3 elements. They don't even have to be just, let's say, A, B, and C. Right? They have nothing in common. This means nothing in common. Their intersection, what do they have in common? is nothing, right? That's nothing. So it occurs when A intersect B is empty. So the answer is 5 plus 3, otherwise known as 8. So you could put 5 plus 3 in there, or just put 8. Now, yeah, all right. I'll let you deal with that when you do the similar problem. The similar problem, it's not 5 and 3, it's M and N, where M is bigger than N. Okay. All right, let's move on to the next one. So what's the the minimum amount of elements that A union B could have? Okay, let's see again here. Let's see, go like this. A, B, 1, 2, 3, 4, 5, 6. Okay, so A union B has how many elements now? Let's see. A union B, putting everything into one set, has 6 things, right? Now, could we possibly make it smaller? Right? What if we put 6 also in there? Right? What if we put What if we put 6 also in the intersection? All right, so let's do that here. Oh, okay. Now there'll be a problem, right? If you put a 6 in there, then we got an issue, right? Because A is supposed to have 5 elements, and now A has 1, 2, 3, 4, 5, 6. Okay, so there's a problem there. That's not going to work. But what if we did this? Oh, okay. Right. This is A. This is B. Now you see A has 5 elements, 1, 2, 3, 4, 5, and B has 3 elements, 3, 4, 5, and the union has 5 elements. Do you see why that has to be the smallest? So think about that a little bit. Let's see. Yeah, okay. So our answer here is 5. Okay. And now we're looking at the intersection. So is there a way that we could still have A having 5 elements and B having 3 elements that we increase this number? All right, I think many of you probably see that. Let's see, and if you don't, it's no big deal. We're gonna see it now. Right, if you put 3, 4, 5 in there, right? Now see what's happening. A still has 5 elements, 1, 2, 3, 4, 5. B still has 3 elements, 3, 4, 5. And the intersection has 4, 5, and 6 in it. Let's see if I can squeeze one more in there. So now we have 3. Right, so this situation really, what does this situation really look like, right? It's really something like this. B is a subset, right? So you have 1, 2, 3, 4, 5. All right, so this is B here, is this set, and then A is the bigger set. So the maximum occurs when B is a subset of A. That's the biggest you get B would be 3. Okay, now the minimum. What's the minimum we could have, right? So the minimum happens when they have nothing in common, right? So if you have something like this, A and B, let's see, 1, 2, 3, 4, 5, 6, 7, and 8. See the minimum, so then A intersect B is the empty set. So the cardinality of A intersect B is the cardinality of the empty set, which is 0. So we have 0. Now maybe you want to think about that a little bit. So I would draw some pictures. Try and make yourself understand this. Don't just take my word for it. Oh, that's how he showed me how to do it, so I got it. Really try and force yourself to understand it. These operations, intersection, union, come up all the time. Programming, I've used them, and they come up in like databases, SQL, SQL, however you want to call it.